Okay, geometry, this is the last lesson. This is lesson 12, homework 12. And there's really nothing new to this. This is the same stuff we did in homework 11. Um, so the scale factor, if the dimensions of a solid are multiplied by a scale factor of a, then the surface area is multiplied by a scale factor of a squared, and the volume is a cubed. So I'm going to do this kind of the same way we did the previous lessons. So if the dimensions of a figure are doubled, let me write out the three quantities we talked about. So length is a to b, area a to b squared, and volume a to b cubed. So they gave us the dimensions of a figure are doubled, meaning the length was doubled. So that means my length is 1 to 2, or 2 to 1 for my scale factor. That means my area is 1 to 4. We just square both of those quantities. So we would say 4. 4 times bigger. All right. Let's look at another one here. Once again, I always write out these dimensions. All right, and the surface area of a figure, they're telling us is 736. And then if the dimensions are multiplied by 1 to 4, what will the surface area of the new figure be? Okay, so when they're saying the dimensions are multiplying, they're giving us the scale factor or the ratio of a to b. So they say the surface area of one figure is 736, and the new figure is going to be multiplied by 1 4, so it's going to be smaller. So they actually gave us the surface area of the large figure. Because if we're shrinking this figure, then obviously the surface area is going to shrink. So what we want is this value x right here, which is the smaller surface area of the smaller figure. All right, so I'm going to set up this proportion then. 1 to 16. Because the surface area ratio would be, you just square both of these, you get 1 to 16. And then we can set it equal to the small surface area divided by the large surface area. And now we have a proportion. All right, so to solve these proportions, we cross multiply. 16x equals 736. Divide both sides by 16, and we get our answer. And it's 46, and that'd be square inches since we're talking about surface area. Okay, so let's try some with volume. Once again, I like to write out my length, area, and volume. Length is a to b, volume a to b squared. I'm sorry, area a to b squared and volume a to b cubed. So they're telling us this time the dimensions are multiplied by 4. So they're telling us that the scale factor is 1 to 4 or 4 to 1. All right. How many times larger will the volume be? Well, that's going to be 4 cubed, which is 64. So 64 times bigger. All right, let's try another one. Okay, so write out our information again. I like to write this out every time. Just keeps me organized. Up to you whether you want to take this approach or not. But they tell us the volume of the figure is 972, and then the dimensions are multiplied by 2/3. So we know the scale factor, or the ratio of length, is 2 to 3. All right, the volume of the new figure then, so this must be the volume of the large figure, 972. Because if we're multiplying a figure by 2/3, that's 66%, 67% of the original. So we're getting smaller by about, a third. So we want us to find the volume of the smaller figure then, right? Well, let's compare that to our volume ratio, which would be 8 to 27, because we would cube both of these to get a to b cubed. Now, once again, we have our proportion that we can solve by cross multiplying. I think you guys can divide both sides by 27 and get the answer for that. And the answer would be 288. And then we're talking about cubic meters because, we're talking about volume. Okay, so pretty simple if the figures are similar, right? Because all the dimensions are changing the same. All right, but the question is what happens if we change only one dimension? All right, changing only one dimension means the figures are not similar. All right. Therefore, we need another strategy. In this situation, this author likes to choose test values and calculate the old and new surface area, and then compare your answers. All right. You're more than welcome to do that. What I'd like to do here is how many times larger is the volume of a cylinder if its height is doubled. Write out the formula for volume. So the formula for volume of a cylinder is area of the base times the height. The area of the base is a circle. Pi r squared times the height. So this is the volume of, I'm going to call this the old cylinder, or the, maybe I'll call A and B. It's the volume of A. Okay. All right. Now, if the height is doubled, we're going to call that b. All right. Now, if we double the height, what we're talking about doing is taking the old, right, and we're doubling the height. So all we're doing is taking this dimension and doubling the height. All right. Now, order doesn't matter when we multiply, so we can take that 2 and put it out front, and then we have 2 pi r squared times the height. So all I did was rearrange the order. And this right here, this pi r squared times the height, is the volume of A. So it's twice the volume of A if I just substitute in the volume of A right here. So we would say 2 times. The volume is 2 times larger. All right, let's try a couple more here. Number 11. This says how many times smaller is the surface area of a sphere if the radius is multiplied by 1/2. So the surface area of a sphere is 4 pi r squared. All right. Now the radius is multiplied by 1/2, so I'm going to call this surface area of A then. All right, and my new one. All right, so the surface area of B is going to be the radius multiplied by 1/2. All right. Now I'm going to rearrange this, so 1/2 squared. I can square that quantity inside and turn that into 1/4. So I'm going to make this 4 pi times 1/4 r squared. So all I did was evaluate this 1/2 squared, right? Because when you square this, you have to square both quantities. Now, once again, order doesn't matter when we multiply, so I'm going to rearrange this and make it 4 times 1/4 times pi times r squared, and the 4's cancel, and I just get pi r squared. So when I compare, the surface area of B, let me rewrite it. The surface area of B is just pi r squared, where the surface area of A is 4 pi r squared. So it's 1/4. All right, when you compare these, if you want to divide them, you can divide them. But basically, if one radius is cut in half, the actual surface area is divided by 4 times smaller. So we're going to say 4 times smaller. All right. Okay, so the next one, let's do 13. How many times larger is the volume of a cone if the radius is multiplied by 6? First of all, the volume of a cone is 1/3 area of the base times the height for any pyramid. So it's 1/3 pi r squared times the height. Now I'll call this the volume of A. So the volume of B then is we are going to multiply the radius by 6. So I'm going to take my old volume and multiply the radius by 6. Now don't forget to put that in the parentheses because it's just happening to the radius. We still need to square that. So let's go ahead and square that. That's 1/3 pi times 36 r squared times the height. All I did was evaluate this exponent. 6 squared is 36. Now once again I'm going to rearrange. All right, so I'm going to put the numbers out front. I have 36 over 3 times r squared times height. And the question is, how do I simplify that? And that is 12 r squared times the height. So the volume of A is 1/3 pi r squared times the height. The volume of B is 12. And I'm sorry, I forgot the pi. The pi should still be there. So 12 pi r squared times the height. So let me write that next to each other. Volume of B is 12 pi r squared times the height. So when you compare these quantities, the volume of A to the volume of B, this one is 36 times bigger. And if you're not sure, you can just divide. The volume of B is 12 pi r squared times the height. So volume of B over the volume of A. And the volume of A is 1/3 pi r squared times the height. Obviously these quantities cancel. So you have 12 divided by 1/3. And dividing by 1/3 is the same as multiplying by 3. So just take that 1/3 and flip it and multiply, and you get 36. So we're talking about 36 times bigger. All right. Now this is a really important idea that you're going to see later if you take physics or chemistry. This effect of changing one dimension and what that has. It's kind of a math question that really you're going to get tested on later in other classes. So good thing to practice. Practice it like this. I'd recommend. Now the author of this textbook does recommend another way. So let me do number 9 again that way. If you like this way, use it. But once again, I think just sticking with variables is a better approach, a more powerful approach. But let's try number 9 again, the way the author recommends. Okay, so the author recommends that you, the volume formula is pi r squared. Choose values. It says choose test values and then compare your answers. So how many times larger is the volume of a cylinder if the height is doubled? So let's call the radius 1 and the height 1, and this is for volume of object A. And the volume of object B, the radius is going to stay the same, but the height is going to be doubled, so the height would go to 2. So we'll just compare those. So the volume of A would be pi 1 squared times 1, which is just pi. And then the volume of B would be pi 1 squared times 2, which would be 2 pi. So you can compare that way as well. This way, probably is easier, but I think that the way we were doing it previously is more of a, proof, and I guess more of an algebraic way to do it, which I'd recommend. But either way, this way works great, gets you all the right answers. The important thing is that you understand the concept, and that you learn something. That's really all that matters here. So hope this helps. Hope the homework goes well, and I hope you guys have a great day.